Welcome to the session UI in Detail of the First Steps course. In this session, you will learn how to visually program, to get help, how to read the color coding and the cable display. You will learn to use the Radial Menu and to set render modes. You will discover the different sections of the software and the canvas and viewer interaction. This will help you to autonomously navigate the software. Please open the file UI Detail. Our first topic is visual programming. You can form algorithms by placing components onto the canvas and connecting them with a cable. And that's what we're going to do together now. I already prepared a rectangular surface component, and the output is a surface, and you can get it by clicking on the green grid and dragging a wire. We want to extrude this surface with the extrude surface body component, and now we have to feed this surface into the surface body input. So we plug the wire in and provide this input to the component. Also, it needs a direction and a length for the extrusion, which I provided down here. So please use this Z vector, which has a length of 2.5, and plug it into the direction. And as you can see, the rectangular surface has been extruded and we have a solid body now. I used the number slider for the length, so you can actually click on this white button and slide it up or down. If you would like to change the values of the number slider, the maximum or minimum or both, you can double click on the white button and then set the maximum to something else. So you can actually extrude the surface with another length. The next topic is how to get help. So you are using a component and you might be wondering what inputs it needs, or you are not quite sure how this component can typically be used, or you need some hints. And you get all those things in the component documentation. By right-clicking on the component, you can access it. You click on Show Help, and this pop-up window opens. On top, it's always a picture of the component and a short description. Then you get a short description of all in and outputs, and behind the name you will always get a data type. So this is the data type needed, or the data type that the output has. And then you get some more detailed text and pictures. And here you get a description of the logic behind this component, an explanation, a typical use case, how you can use this component, maybe some hints. And if you scroll all the way down to the end, you will always have an example file. You can open this example file. And as you can see, here you have multiple workflows that all use this extend curve component, and you can take a look at this file and see how it's been used. And then you might think to yourself, oh, this is exactly what I need or what I want, and I can use this in my own workflow, in my own file. And then you don't have to go back to your file and build everything up yourself and take a look how it's been done. You can just recycle what we provide here in the help files and copy a workflow that you need and drop it in your own file. So as you can see, now we have this curve in our own file. Another way to access the help is the component browser. This is this little magnifying glass When you open the component browser, you have to select a component, and then you will get a short description and the in and outputs on the right side. And then you can also open the pop-up window for the help by clicking Open in Separate Window, and then get the help window. It's structured the same way, and also you can open a different tab with an example file. So we already kind of got into tab browsing, which is the next topic. So we have different tabs, and you can open a new tab by selecting this plus, or you use the shortcut Ctrl+N, and then you can close them by using the X. Let's talk about color coding of the components. So we have a color code that we use, and it's very helpful for you to keep an overview about what state the components are in. I'm going to talk you through the different colors. Let's start off with white components. So if a component has this color, it means that the calculation is successful. So there's nothing for you to worry about, everything's working and running. It's good. Then we have this dark gray, and it means, again, everything's running and the calculation is successful. However, it's invisible, so you can't see it in the viewer. And if you want to make it visible, you can right-click on it and select Visible. As you can see, this ellipse appeared in the viewer, and you can also use a shortcut to make it visible or invisible, which is Ctrl+Q. Next, we have this faded gray or see-through gray. And this is something to watch out for, because it means that the component is disabled, it can't calculate, and every time a component can't calculate, because it's disabled, the output will be empty. So everything downstream from this component doesn't get an input and can't calculate. You can enable the component by right-clicking on it and selecting Enabled. Now, as you can see, you do get an output. It's an ellipse, this one, and you can disable the component again, either by using right-click and so on, or you use the shortcut Ctrl+E. You can also have components appearing in yellow, which means that there's a warning. If you hover your mouse to the exclamation mark, you can read what the warning is. In this particular case, it reads parameter curve failed to collect data. So let's see, this is the parameter curve, and yeah, we don't provide any input here, so it fails to collect data. We actually have to connect these. Now we have an input, and as you can see, the component is right because it can calculate and generates this curve. Actually, the snap curve to points component can snap a curve to a point. When we connect the points in here, it snaps. We can also have components appearing in red. Red means there's an error, so that's something to watch out for. Let's see what the error in this particular case reads. It says, no automatic conversion is defined for the following types, body to point 3D. Okay, so this component line wants to create a line between a start and an end. And let's check out the documentation to see what the inputs need. So start and end both need a point 3D. And let's see what input we are trying to plug into there. We use the cone component and the cone output. as you can see, the cone output is a body, not a point 3D. And now it completely makes sense that we get an error because the input is completely wrong. So the tip of the cone actually is a point, so we can use that. And I provided a different point for the end. And now the component can calculate, the error disappears, and we created this line. We're not completely done with the color coding just yet. I would also like to tell you about the color codes for the in and output grids. Let's start with the inputs. And in the first example, you see a filled out green grid with a cable going in. This means there's an input provided and also the input is correct. So the component can actually calculate with this input and run successfully. Then we have these white grids with a green outline and no cable going in. This means that no input is provided. However, a default input is saved in the component, so the component can still calculate successfully. If you would like to know what this default input is, you can hover your mouse over the input name and read, for example in this case, the interval is between 0 and 1. Then we also have filled out green grids with no cable going in. And this is the case when we have an internalized input. If you hover your mouse over the input names, you can read that the inputs are 10 and 2. And you could clear the data by right-clicking onto it and selecting Clear Data. Now we don't have an input. We can feed a new input in here and now internalizing it too by right-clicking on here and selecting Internalize. You can now delete the panel and the input is internalized and can be used. Okay, then there are white grids with a yellow outline. And this means that no input is provided, but this input is crucial and the component can't run without an input being provided. So that's why you get a warning, because this input is needed. Then we have red grids, and this means that there's an error. I used the same example as in the component color code example. So we have a body going into an input that needs a point. And we have a red grid because the component tells us, I can't run with this input. You provided something that doesn't match what I need. Give me something else. So if you have a red input, check for the data type, check what is going on, maybe there's an error upstream from this, and make sure that you get rid of this error. Lastly, you can also have a white input, and that simply means that the input is empty. We have less options for the outputs, so there's only green or white. Let's start with green. If you see this green grid for the output, it means that the component calculated and you actually have an output and can continue from here on. And if the output grid is white, it means that it's empty. For whatever reason, you don't get a result from this component and can't continue from here on. So far, you know two ways to get components onto the canvas. I showed you the ribbon menu on top and also the component browser. There's a third way to get the components onto the canvas, and that's the Radial menu, which is actually super quick and helpful for your work. If you double click onto the canvas, it will open, and depending on where you clicked and what components are close to where you clicked, you will get auto suggestions. So these components are typically used in an area where the other components that are displayed here are already on the canvas. If you don't get suggested what you're looking for, you can also type something in. For this example, please type in arc and select this arc. We're going to place this here. And now I want to show you one more really cool thing about the radial menu. If you drag a wire and you press the Alt key, you can see that there's a plus appearing at the end of your mouse. If you press Alt and then let go while holding Alt, the radial menu will open and suggest components to you that can use the provided input. We're going to deconstruct the arc, and as you can see, the components are already connected. This leads us to cable descriptions or cable display. The first thing I want to show to you are the different cable displays for data structures. So what you've seen already a lot is this continuous line for a cable, and basically this tells you that there's one single data value flowing through the cable. Then we have a dotted line, and this tells you that there's a list of data values flowing through the cable. And then there's also this broken line, and that means that data packages or a data tree is flowing through the cable. Okay, then you can also select display modes for cables. So the default one is this, you can see it very well. Then you can set it to faint, so it's barely there. And you can also go wireless, and you can see the symbol here. So you have a wireless connection. No cable is visible, but these are still connected. To see all cables in the default mode, please press the W key. And if you want to change the display mode, you can right-click on a cable and select a different display mode here. However, you can't select a wireless cable because there is no cable. And if you want to change the display mode for a wireless cable, press the W key, select it, and now you can change the display mode. Lastly, I would like to show what a disabled cable looks like to you. So if there's a red cross appearing on a cable, that means it's blocked, it's disabled, so no data can run through this cable. And you can tell because the output here is empty. This is normally the default mode for a cable. It's enabled, and if you want to disable it, you right-click onto it and deselect enabled. Now it's empty too. And you can also select a cable and press Ctrl E to enable it. Let's talk about solution control. You see what solution control mode you're in down here. And if the play button is selected, that means you're in auto solution mode. And basically, whenever you change an input, everything downstream will recalculate immediately. If you don't want that, you can pause this and go to the manual solution mode by pressing this pause button. And now you can make all the changes you want. Nothing will recalculate, which means that a lot of outputs will be outdated. And then when you decide that you're happy with the changes you made, you need new outputs, you can press the play button and everything will recalculate. While some outputs are outdated or while the calculation is still running, you will see this appearing, this error, and then when it's finished and the calculation has run through, you will see this check. Currently, we don't need the manual solution mode because what we're doing is very simple and the calculations can run through super fast. So if we change something up or we change multiple things up, downstream everything can calculate super fast and it doesn't make sense to go to manual mode. Later, however, if we have components that are more complex and need more time to calculate, for example, the optimization one, it does make sense to go to manual mode if you want to change inputs, change all the inputs that you want to change at once, and then let the component recalculate. Our last topic is rendering and zoom. In the bottom of the viewer, you find these 3 buttons. With the first one, you can set the render mode. You could set it to wireframe, to shaded, or to shaded with edges. If you have meshes, it might make sense to use the Show Mesh Facet Edges render mode. Then the next button is the Zoom to All. If you scroll in a bit further and you click on this button, it will adjust the camera so that everything displayed fits into it. If you zoom out and you select it, it will zoom in as much as it can. Now, if you select something, a component in the canvas or a displayed component in the viewer, and select the Zoom to Selection button, the camera will adjust to show the selection. In this session, you learned about all the details of the user interface. Now you are able to completely autonomously navigate the software.